Okay, so in this segment we're going to talk about the differences between the terms and the quantification of precision and accuracy. So I'm going to zoom in here a little bit again. We're on the back side. The notes, precision versus accuracy. Use my pen. And okay, so precision is the term we use for measurements, how close let's actually do this. Let's put how close on top. How close measurements are to each other. And oftentimes we don't have like a real value. It's just based on, you know, what we've done so far is eyeballing, and my eyeball is as good as your eyeball, right? And so there is no accurate value that we can go look up. So this is precision. So we talk about, so we do it multiple times, and if we come up with the same answer, then we're very precise. If we get different answers, then we're not so precise. The way that we quantify precision is by taking an average, and then that should make sense. So we take the average of all the values we measure, and we say the average plus or minus what we call the deviation, which is also like the range of values. The deviation is like the range. And it's the deviation from the average that actually tells us the precision. The average is like the middle value, and the deviation from the average is what is actually the precision. So let's put a box around the deviation. But we need to have an average in order to see what the deviation is, how far from the middle, right? So to calculate the average, of course, we add up all the values and we divide by how many values there are, right? I think calculating average is something most of you have done, so we add all the values, the quantities, and then we divide by the number of values. Okay, so that we write a number for average, and then we put this little plus minus here. That means plus or minus. And we take, to calculate the deviation, we take the maximum of our values, the maximum, the biggest number, minus the smallest number, the minimum, okay? And we have to divide that by 2 to get the deviation away from the middle. Okay, so that's how we do it, average plus or minus the deviation. I'm going to come over here to the example, and we'll see if this makes sense. So we have 2 groups making measurements using a centimeter ruler. Group A and Group B, and Group A comes up with, you can see here, these values. So we're going to calculate their average. We're going to add up all of these numbers, and we're going to divide by 4. And what we get is 320. All right. That's their average. The average for Group B, when we add up these 4 values here and divide it by 4, we get 325. Okay. So then we talk about the deviation. We're going to take the maximum value for Group A is right here, 330. That's the biggest value. 310 is their smallest value, so there's their minimum value. So we take the maximum minus the minimum, and then we have to divide it by 2. So 330 minus 310 is 20, divided by 2 is 10, okay? So that's 320 plus 10 would be 330. 320 minus 10 would be 310. All right, for Group B, their maximum value is 328, and their minimum value is 321. So we take 328 minus, what did I write 3, 2, 1 there? That's funny. I just copied that. I need min. Okay, 328 minus 321 is, what is that, 7? Okay, and divided by 2 is 3.5. So 325 plus 3.5 is going to be pretty close to 328. 325 minus 3.5, is that right? Minus 3, yeah, it's about 321. That seems weird. Okay. So then the question is, who is more precise? So that's down here. Okay. Which group is more precise? Well, the precision is based on how close they are to their average. Okay, so actually group B is more precise. So let's put this here. Group B here is more precise. Okay, so let's go back to the notes on this side over here. We'll talk about accuracy. So accuracy then is how close, whoops, hello, how close measurements are basically to the correct answer. To a correct, and we don't actually have a correct, we have just the most accepted value. So we use the best method that we can. We have at our access, and we come up with values. So density is an example of a measurement that would have accuracy. You can look up the density of any substance in a handbook of chemistry and find the accepted value for density. Okay, the way that we quantify accuracy is what we call the percent error. The percent error. Okay, and to calculate the percent error, we take what is the accepted value. Oops, I'm going to run out of space here. Minus what we got, so the experimental value. Okay, and we have to put that in parentheses here. And we're going to divide that again by the accepted value. So it's the proportion of the difference. I don't know if that makes sense. So the difference is up here. This is the difference between the right answer and what we got. And it's the proportion of that, of the difference to the right answer. Okay, so just, if nothing else, just remember, and we may want to, I'm going to use a black here and put a box around how we quantify. Okay, and you may want to put a box around up here too about the average plus or minus the deviation for precision. So the percent error, it's the proportion of the difference to the correct answer or the accepted value. So let's go look at an example. Again, I'm going to move this over to the example point. Okay, so this is not actually a value that would have an accepted value, an accuracy, but if the actual length of this measurement that these groups took is 321 centimeters, what is the percent error of each group's average measurement? Okay, so here's the average measurement for group A. Here's the average measurement of group B. Okay, so group A, the accepted value is 321, so we're going to take 321 minus 320. Okay, so that's 1. And then divided by 321. And then in order to get the percent, I forgot this part, you have to multiply by 100. So I end up with 0.31%. Okay. For group B, and I have to erase my B down here. Oh, it's not going to let me. That's interesting. Okay. I'm going to use a different color here. Okay, for group B, we have the accepted value, 321, minus what they got, which is 325. And I'm going to divide that again by 321. And I'm going to multiply it by 100 just to change it from a proportion to a percent. And I get a negative, and that's fine. The negative just says that the value that you got was higher than the accepted value. It was a bigger number rather than a lower number, and then we get negative 12%. Okay? And really, what we compare is we want the absolute value. So 12% is the same as negative 12%. So we really care about absolute value, which would be 12%. Okay? So now we can ask ourselves the second part of this question here. The first part was which group is more precise, and we decided that Group B's values up here were closer together because the difference, right, the deviation from the average was only 3.5. Who's more accurate, though? And that's going to be Group A, right? So Group A is more accurate. I'm going to rewrite this. Group B is more precise. And that's because their values are closer together. Their deviation is smaller. Deviation is smaller. Okay. Group A, though, is more accurate because their percent error is smaller. Okay. So then there's just one more thing about accuracy and precision, and this is kind of a visual. So over here in the bottom left-hand corner of your notes, we sort of look at this dartboard, and here, if we think about accurate, it's going to be hitting the middle of the target. These arrows in example A here are all very accurate because they're close to the bullseye. They're also close together, so we can call that accurate and precise. Here's an example where they're very close together, so they are very precise, but they're not accurate because they're not hitting the bullseye. This third example here, the arrows are far apart, and so they're not precise, and they're also not hitting the bullseye, so they're not accurate either. Okay, so I hope that that gives us an idea of accuracy and precision and how we calculate it, and you're going to practice with this now with your worksheets, and I will see you tomorrow.